A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. You know, Herman, I was looking at the Hugging Face hub the other day, and it struck me that we treat it like a giant library, where most people only ever visit the new releases shelf and the fiction section. Everyone is obsessed with the latest large language models or the newest image generators, but if you actually wander into the stacks, there is this incredibly dense, almost overwhelming taxonomy of AI capabilities that most developers haven't even touched. Today's prompt from Daniel is about exactly that, digging into those niche task classifications like mask generation, key point detection, and visual document retrieval.
It is a massive map of human ingenuity, Corn. As of right now, in March 2026, Hugging Face is hosting over 500,000 models. That is 500,000 distinct weights and architectures. And while everyone talks about AI as this monolithic thing, the platform actually breaks it down into very specific functional buckets. By the way, before we dive into the deep end of computer vision, I should mention that today's episode is powered by Google Gemini 3 Flash. It's helping us navigate this granular world of specialized models.
500,000. That's a lot of models just to ask for a poem about a toaster. But Daniel's point is that the real workhorse models aren't always the ones generating headlines. They're the ones doing things like panoptic segmentation or zero-shot object detection. Herman Poppleberry, I'm looking at you to help me make sense of the computer vision section specifically. When we move past, this is a picture of a cat. What are we actually looking at?
We are looking at the transition from understanding a scene to interacting with a scene. If you look at the computer vision category on Hugging Face, you'll see tasks like mask generation and key point detection. These aren't just fancy versions of classification. In classification, the model outputs a label. In mask generation, the model is essentially doing digital surgery. It's identifying every single pixel that belongs to an object and creating a binary mask for it.
So, instead of a bounding box, which is just a lazy rectangle around a dog, a mask is a precise outline of the dog's ears, its tail, and its paws.
Precisely. And the breakthrough that really put this on the map for the general public was Meta AI's Segment Anything model, or SAM, which came out back in April 2023. SAM introduced what they called promptable segmentation. You could give it a single point, a box, or even a text prompt, and it would generate a pixel-perfect mask for that object, even if it had never seen that specific type of object in its training set. It's called zero-shot generalization.
I remember when SAM dropped. It felt like magic because you could click on a shadow or a weirdly shaped rock in a blurred background, and it just knew the boundaries. But how does that work under the hood? Is it just looking for color changes at the edges?
It's much more sophisticated than edge detection. SAM uses a heavy image encoder, usually a vision transformer, to produce an image embedding. Then it has a very lightweight prompt encoder that takes your clicks or boxes and translates them into sparse embeddings. These two are mashed together in a mask decoder. The genius is in the training data. They trained it on over 1 billion masks on 11 million images. Because the decoder is so light, you can run the actual segmenting part in a browser in milliseconds once the image is encoded.
That explains why it's so snappy. But let's talk about key point detection. That sounds like something a chiropractor would be interested in. Is this just finding elbows and knees?
In the context of pose estimation, yes. But key point detection is broader. It's about identifying specific, predefined points of interest in an image. Think about facial landmarks for filters or security, mapping the corners of the eyes, the tip of the nose, the edge of the jaw. Or, in industrial settings, identifying the specific corners of a mechanical part so a robot arm knows exactly where to grab it.
I've seen this in sports tech too. Those apps that analyze your golf swing or your basketball form in real time. I assume they aren't using a massive transformer model for that if it's running on a phone.
You're right on the money. A lot of those use architectures like MediaPipe from Google. As of the 2024 and 2025 updates, these models can track 33 different body key points at over 30 frames per second on a standard mobile device. They use a heat map-based approach where the model predicts the probability of a key point existing at every pixel, and then they use a regression head to fine-tune the exact coordinates. It's the difference between knowing there is a person here and knowing this person's left elbow is at exactly XY coordinates.
It's fascinating because it feels like we've moved from AI being a spectator to AI being a surveyor. But then there's image segmentation, which you mentioned earlier. Hugging Face lists semantic, instance, and panoptic segmentation. That sounds like a law firm. What's the difference?
It's a hierarchy of complexity. Semantic segmentation is the color by numbers version. Every pixel gets a category. If there are 3 dogs in the photo, all those pixels are just labeled dog. You can't tell where one ends and the other begins. Instance segmentation is the next step up. It identifies individual objects. It says, this is dog 1, this is dog 2.
And panoptic is the final boss.
Panoptic is the holy grail. It combines semantic and instance segmentation. It identifies every individual object, the things, and also classifies all the background elements like the sky, the road, or the grass, the stuff. Models like Mask RCNN or the newer YOLO V8 Seg are the workhorses here. They use a backbone to extract features and then have multiple heads. One head proposes where objects might be, another head classifies them, and a third head generates the mask.
You know, I was reading a paper about how this is being used in self-driving cars. It's not enough for the car to know there is a road. It needs to know this is the drivable surface of the road, versus this is the curb, versus this is a puddle that might be a deep hole. The precision of panoptic segmentation is literally a matter of life and death there.
It really is. And what's wild is that we're seeing these models get smaller and faster. We used to think you needed a server farm for this, but now we have segmentation at the edge, where the processing happens right on the camera sensor.
Okay, so we've conquered the vision part of the library. Let's head over to the multimodal section. This is where things get really weird and, frankly, a lot more useful for the average office worker. Daniel mentioned visual question answering, or VQA. Is this just me asking an AI, hey, what color is the shirt this guy is wearing?
That's the basic version, yes, but VQA is the bridge between sight and logic. To answer a question about an image, the model has to do 3 things. Understand the natural language of the question, recognize the visual elements in the image, and then perform a spatial logical join between them. If I ask, is the cup to the left of the laptop open? The model has to find the laptop, find the cup, determine the spatial relationship, left, and then analyze the state of the cup.
That sounds like a massive computational headache. How do you even train a model to do that? Do you just feed it photos and captions?
Not just captions, but triplets. Image, question, and answer. Early VQA models used a 2-tower architecture. One tower processed the image using a CNN, the other processed the text using an RNN or a transformer. They would then fuse those 2 vector representations in a co-attention layer. But the modern approach, like what you see with models like LLayoutLM or the vision-enabled versions of Claude and Gemini, is much more integrated. They use a unified transformer architecture where the visual tokens and text tokens live in the same high-dimensional space.
So, the model doesn't see an image and read a sentence, it just sees a sequence of tokens where some represent patches of pixels and some represent words.
That's exactly how the modern multimodal landscape works. It's why document question answering, or DQA, has become such a massive niche on Hugging Face. DQA is a very specific subset of VQA. If you give a standard vision model a photo of a messy insurance form, it might struggle because the meaning of the document isn't just in the text, it's in the layout. A checkbox next to the word yes means something very different than a checkbox next to num.
I've dealt with this in my own work. You try to OCR a table, and the text comes out as a jumbled mess because the OCR engine reads left to right across the whole page, ignoring the columns. DQA models actually understand the grid, right?
They do. They use what's called LayoutLM or similar architectures. These models are trained on the spatial coordinates of every word. When the model looks at a document, it doesn't just see the word total, it sees total, at coordinates x, y, followed by a $sign and a number to its right. It's essentially visual OCR. This solves the huge problem of form fatigue in industries like law, insurance, and banking. Instead of a human spending 8 hours a day transcribing data from scanned PDFs into a database, a DQA model can extract specific fields with a high degree of confidence.
And if the confidence is low, it just flags it for a human to check.
That's the human in the loop workflow. But what's even cooler is the next step, visual document retrieval. Imagine you're a lawyer and you have a million scanned documents from a discovery phase. You aren't just searching for the word contract, you're searching for documents that look like this specific type of NDA.
Oh, so it's like a visual find similar for documents.
Yes, it uses vector embeddings of the visual layout. It's not looking at the text, it's looking at the fingerprint of the document structure, the headers, the signature blocks, the logo placement. It converts the entire visual structure into a single mathematical vector. When you search, you're just looking for the closest neighbors in that vector space. It's incredibly fast and ignores things like typos or poor OCR quality because it's looking at the soul of the document's layout.
The soul of an NDA. That's a bleak thought, Herman. But I see the utility. It's like how Google Images lets you search by image, but specifically tuned for the boring, beige world of corporate paperwork.
Boring, but lucrative. And this is where the Hugging Face taxonomy becomes so important. If you just search for AI model to help with your business, you might end up with a massive LLM that is total overkill and actually quite bad at spatial reasoning. But if you go to the document question answering task page, you find models like DONUT, which stands for Document Understanding Transformer, that are specifically designed for this without needing an expensive OCR engine as a middleman.
Donut. I like that. Finally, a model name I can relate to, but it brings up a good point about the slob reckoning we've talked about before. Are we using these massive, multi-billion parameter models to do things that a small 500 million parameter specialized model could do better?
In many cases, yes. A specialized key point detection model is going to be faster, cheaper, and more accurate at finding a human's wrist than a general-purpose vision transformer like GPT-4o. The general model is distractible. It might get interested in the background scenery. The specialized model has one job and it does it at 60 frames per second.
It's the difference between a Swiss Army knife and a dedicated scalpel. You can try to cut a steak with a Swiss Army knife, but the guy with the steak knife is going to have a much better time.
That's a good way to put it. And when you look at the real-world applications, it's everywhere. Take image-to-text models that aren't for captions, but for optical character recognition in the wild. Imagine a delivery robot trying to read a house number that's partially obscured by a vine. A general model might say a house with plants. A specialized OCR in the wild model is going to focus specifically on the high contrast strokes of the numbers.
What about the mask generation stuff in a practical sense? Beyond just cutting out the dog, where does that actually impact someone's life?
Medical imaging is a huge one. If you're a radiologist, you don't want a bounding box around a tumor. You want a precise mask of the tumor's volume, so you can track if it's shrinking by millimeters over time. Or, in agriculture, drones fly over fields and use semantic segmentation to identify crop versus weed. Then, they can trigger a targeted spray of herbicide only on the weed pixels. It reduces chemical use by 90%.
See, that's the stuff that gets me excited. The headline, AI is cool for writing emails or making funny pictures, but the granular, AI is literally saving the environment and treating cancer. It's much more grounded.
It's also much more accessible for developers. If you go to Hugging Face, you can often find a model that is 95% of the way to solving your specific niche problem. You don't need to be a PhD in machine learning. You just need to understand which task classification fits your problem.
So, if I'm a developer listening to this, and I have a problem that isn't write a chatbot, where do I start? Do I just click on every category on Hugging Face until something looks familiar?
I would start with the Tasks page. Hugging Face has a dedicated section at huggingface.co/tasks. It's a brilliant directory. If you click on Key Point Detection, it doesn't just give you models, it gives you a 101 on how the task works, what datasets are used to benchmark it, and even a little widget where you can test a model in your browser.
It's like a choose-your-own-adventure for engineers. But I have to ask, is this granular taxonomy going to survive? Or are we moving toward a world where one supermodel just does everything? Does the key point detection category disappear because Gemini or Claude just knows where the elbows are?
That is the multi-billion-dollar question. We're seeing a trend toward foundation models that are multimodal from birth. However, there is a fundamental limit called tokenization and resolution. A general-purpose model usually sees an image at a relatively low resolution, like 512 by 512 pixels, because the computational cost of looking at a high-res image is quadratic.
Right, if you double the resolution, you quadruple the work for the attention mechanism.
Oh, I mean, you're spot on. Specialized models can use sliding windows or specific architectures that allow them to look at a 40 megapixel medical scan in extreme detail. A general model would just choke on that. So, for high precision, high speed, or high resolution tasks, I think these niche categories are safe for a long time.
That's a relief. I like the idea of a diverse ecosystem. It feels more robust than just having one giant brain in a vat that we all have to rent time from.
It's also better for privacy and on-prem deployment. You can run a specialized document extraction model on a single GPU in your own office without ever sending sensitive legal data to the cloud. That's a huge selling point for those niche models.
It's funny, the more we talk about this, the more I realize that the boring parts of Hugging Face are actually the most revolutionary. We're so focused on the AI that can talk back to us. We're ignoring the AI that can actually see the world with more precision than any human ever could.
It's the silent revolution. It's happening in the code bases of logistics companies, in the software of surgical robots, and in the background of your favorite photo editing app. When you use Magic Eraser on your phone, you are using a combination of object detection, mask generation, and image inpainting. You aren't talking to an AI, but you are benefiting from a chain of 3 or 4 specialized models working in sequence.
I wonder if we'll ever reach a point where the taxonomy gets even more granular. Like, instead of mask generation, we have transparent object mask generation, because glass is so hard for AI to see properly.
We're already there. There are specialized models specifically for refractive surface segmentation, because, as you said, glass and water distort the background, which confuses standard models. There are researchers who spend their entire careers just on human hair segmentation, because hair is so fine and complex.
That is peak nerd, Herman. I love it. Someone out there is the world's leading expert on AI for curly hair outlines.
And thank goodness for them. Without them, your virtual background on this podcast would look like a jagged mess around your ears.
Hey, my ears are perfectly segmented, thank you very much. But this brings us to the practical takeaways. If you're a business owner or a curious tinkerer, the lesson here is, don't reach for the biggest hammer in the shed first.
Precisely. Start by defining your task. Are you trying to find something? That's detection. Are you trying to outline something? That's segmentation. Are you trying to understand a relationship? That's multimodal VQA. Once you have the task, you go to Hugging Face, look at the leaderboard for that specific task, and see which model has the best balance of accuracy and speed for your needs.
And don't be afraid of the specialized datasets. One of the things I've noticed is that these niche models often come with incredible datasets that you can use to fine-tune your own version. If you're trying to detect cracks in aircraft wings, you don't start from scratch. You find a surface defect detection model and give it a few hundred photos of wings.
That transfer learning is the secret sauce. You're standing on the shoulders of giants, or at least very specialized, very focused giants. And most of this is open source. That's the most incredible part. The models Daniel mentioned, like SAM or LayoutLM, have their weights publicly available. You can download them, look at the code, and run them yourself.
It's a good reminder that while the AI world feels like it's being captured by 3 or 4 big tech companies, the actual toolbox of AI is still very much in the hands of the community. Hugging Face is the town square for that.
It really is. And I think we're going to see even more multimodal fusion in the next year. We're already seeing video-to-video tasks where the model doesn't just segment a frame, but maintains temporal consistency, knowing that the car in frame 1 is the exact same instance as the car in frame 60, even if it went behind a tree for a second.
That's object tracking, right? Another niche category.
It's instance segmentation plus time. It's getting to the point where the AI doesn't just see a snapshot, it understands a narrative.
Well, before we get too deep into the philosophy of AI narratives, let's wrap this up with some actual advice for the people listening. If you want to explore this, go to the Hugging Face tasks page. Don't just look at the models, look at the spaces. Those are the little demo apps people build. You can upload your own photo and see how a key point detection model sees your face or how a document QA model reads your grocery receipt. It makes the abstract feel very real.
And it's fun. There is a genuine sense of wonder in seeing a model solve a visual puzzle that would take a human a lot of tedious effort.
I think that's a perfect place to leave it. We've gone from the new releases shelf all the way back to the niche technical manuals section of the library. And honestly, the manuals are a lot more interesting than the bestsellers.
They usually are. Thanks for digging into the taxonomy with me, Corn. It's always good to remind ourselves that the AI we talk about every day is just the tip of a very large and very granular iceberg.
An iceberg that's been perfectly segmented and masked by a specialized vision model, no doubt.
No doubt.
Huge thanks to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes. And a big shout out to Modal for providing the GPU credits that power our research and the generation of this show. If you're building your own niche AI applications, Modal is the place to run them.
This has been My Weird Prompts. If you enjoyed this deep dive into the Hugging Face woods, consider leaving us a review on Apple Podcasts or Spotify. It's the best way to help other curious nerds find the show.
We'll be back next time with whatever weirdness Daniel throws our way. Until then, keep your key points detected and your masks precise.
Goodbye, everyone.
See ya. This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our